Hi, back in video number 975, 6 years ago. Whoa. I did a very popular video where I pitted my PCB routing skills against Altium's autorouter to see which one could do a better result on my Nixie Tube project, which was like a 5 or 6 part video series, if you haven't seen it, where I did design this Nixie Tube project for my YouTube Silver Award thing. Anyway, both linked in down below if you haven't seen it. And TLDR is that, nah, the auto router was, nah. It was, no. I was, I don't want to brag, but I was much better than the auto router. Now, as a former professional PCB design engineer who did routing every single day, like for decades. Yeah, auto routing is actually useful, but as I've said many times before when discussing auto routers, is that it sometimes takes more time to set up the auto router properly, all the parameters that go into, all the constraints and parameters behind auto routing before you hit the auto router button. You can't just place your components and just hit the auto router and magic happens. No, it doesn't work. Auto routers are actually incredibly useful for lots of, especially the more complex a PCB gets, like, motherboards and things like that, incredibly complex things. Usually not going to 100% hand route those. You'll probably set up a lot of constraints, but you could spend a week setting up constraints before you hit that auto router button, and then it can actually produce really good results. But anyway, in this particular example, which was a double-sided board here, the one on the top is the auto router result, the one on the bottom is mine. So yeah, anyway, you can check that out. There's the bottom, there's the top. I've put in a nice ground fill and everything else. Anyway, yeah, the Altium auto router didn't do a very good job, but it can if you set it up and constrain it correctly. But a lot of people, for quite a few years now, in fact, I checked my emails, someone sent me this in 2019, there's an AI, because AI is all the rage. There's this company called DeepPCB who have an AI auto router. Now, there's nothing new about supposedly magic auto routing, AI technology. It's been going back many, many decades. Neural net routing was all the rage in the 80s and 90s and stuff like that. And they had fuzzy logic and they had all sorts of, every manufacturer had their own, trademarked flavor of auto router that sort of pretended to be machine learning, AI and all that sort of stuff. But of course, AI these days, it's pretty advanced, as I've done videos on. So I thought I'd try this. So this DeepPCB, people have been asking me to give this a go. So I thought I would take the exact same file out of this that I use for this example, so that we'll have a comparison with my routing, with the Altium routing, with the Altium auto routing, and then try this AI. It's still beta version 1.000, so I don't know what they've been doing for 4 years or whatever, but anyway, some people say it's pretty good, others go, meh. Now, of course, the big thing with auto routing, one of the big things is placement. As I've said before, PCB layout is like 90% placement, getting the placement right. Now, as I've already placed these components, what I'm going to do is take the existing board file, I'm just going to unroute it. So it's reasonably good placement, done by a verified human, and I thought we'd just load that in there and see if it can auto route. Pure AI-powered, cloud-native PCB routing, design complex boards in less than 24 hours. So I can't do this live right now. I think I have to wait a day, and it's free for 2-layer boards, I believe, because it's still in beta or whatever. Upload your board. Our fully automated, no human in the loop cloud platform gets to work as soon as it receives your .dsn PCB file. No time wasted. Distributed machine learning. Our beta release covers the following features: routing for printed circuit boards up to 150 pairs. 2 layers is currently available. I'm not sure what the 150 pairs is. Is that controlled impedance pairs? I'm not sure what the deal is. All our boards are DRC checked, fully compatible with KiCad, leverages innovative InstaDeep AI technology combined with powerful GPUs and cloud infrastructure to offer the first pure AI PCB routing engine. Results in 24 hours, not weeks or months. Save time, accelerates. Well, if it's a 2-layer board, like, it's not going to take you weeks or months to lay out the board usually, unless it's an absolutely massive board. Your questions answered. Are you doing this manually? I would bet you have humans in the loop. Actually, DeepPCB is a fully automated tool. Currently in beta, automation is possible thanks to reinforcement learning and AI technology particularly suited to decision-making problems, board games such as chess or Go, logistics, mobility, or PCB routing. InstaDeep. So there you go. Anyway, I'll link it in down below. Apparently there's no humans in the loop. So apparently all it supports is a .dsn file. So that's an ORCAD Spectra file. So unfortunately, my Altium license, and yes, I know the irony of this, it has expired, and yeah, they won't give me another one just for like educational use or whatever. So anyway, I can't export my original project here, but thank you very much. A couple of people I asked on Twitter, a couple of people did that. They unrouted it for me, saved it as a DSN file, and well, we're going to give it a whirl. All right, so let's drag open the DSN file, submit, and apparently it will display like a preview image or something. Price, free, thank you. Number of layers, number of air wires, 238, number of pins, 363. Nah, I can't even get board information. I can't get anything. Anyway, I presume it'll do the full thing. I hope it's within the constraints. It's not a huge board. So let's confirm. Okay, free. Done. Order placed successfully. My board. So I can view it, presumably. Board processing. Okay, I'll get back to you. It's running. It's doing its business. Will this be like a live update? That'd be really cool. And of course, you don't want to sit there watching the AI do it, do you? You know, you just want to, like, send me an email when it's done, please. Routing from empty board. Yeah, it knows there's no traces there. I haven't told it anything about ground planes or anything like that. Whether or not it actually is smart enough to like whack down a ground plane under all that. Not that it's needed on something like this. It's just, you know, it's just the done thing. It's the vibe thing, because this is a Nixie tube project that, you know, reasonably high voltage DC stuff. So clearance is important. So once again, all that clearance sort of stuff would be part of your manual constraints when you're setup constraints for your auto router. There you go. Completed in 4 minutes. What? It's 4? No, it's still running. I was excited there. It looks like it's done 117. Yeah, there you go. It changed from 117 to, oh, look, it's doing it. It's doing it live. I thought this would be like a 24-hour thing. Look, it's got these, yeah, you can see my cursor there. It's got like non-right angle traces coming out. That's just a no-no, okay? That's what the Altium autorouter did, but I don't know if this is like an intermediate route or it's a final route or anything like that. Now, look, I'm going to forgive anything to do with like clearance constraints for the high voltage, you know, part of it. So I'm just going to ignore that. But look at this. Look at these traces up here. Okay, it's just why not continue that across there and go down? So let's go to my board over here, and it was obvious that this like common, right, high voltage anode, I think it is, like line, that's a common thing for all of those displays. So any human, right, would know, like, you kind of route that first, right? It's a high voltage line, so you like snake it around the outside, so it's got clearance from everything else, and it goes to these dropper resistors down in here like this, okay? And then it's common to all of them. So like that was one of the first things that I routed as a human. Right, and then it's no, but this thing, right, it's dropped vias down there, right? Oh no, oh this is terrible, Muriel. Whether or not, I assume it's a rip up retry like algorithm, as it's called. That's the industry term for when, if you get sort of like locked in, it's going to change when you get like locked in, sort of like constrained in, you might have to rip up some traces, and it can't figure out any way in, so it has to rip up some traces and then retry again. Yeah, it is definitely rip up and retry. It definitely changed. I was just explaining how it put a via in there and jumped over that high voltage line over there, and it's just ripped up that and completely redone it. See, but it doesn't know because we haven't told it. But you know, these are the things humans know, right? And the AI can't possibly know that because it doesn't have any schematic information. It's got no knowledge of what the circuit's doing or anything like that. It's just routing. So, you know, once again, this is where, like, you could utilize a tool like this, and you could partially route a board. Like all the important stuff you could route, and then the unimportant stuff you just let the auto router rip. And as a professional PCB designer, that's what I've done countless times before. It's like, oh, I've got all this digital crap and I've got to route 1,000 traces, and they're just like low frequency stuff. It doesn't matter. They're just all, or whatever, or you're routing like big buses or something like that. And you can just let it do all that sort of like unimportant stuff, but the important stuff you've got to do yourself and set as a priority. So I guess I can't blame it. I can't blame it for not getting that, but it's doing this live. This is pretty cool. Doesn't look like it's going to be any better than the Altium auto router, which is the one up the top here. But yeah, once again, like all the traces up the top here, it's done a similar sort of thing. Like, it's just, no. Yeah, it's just like taking them through the middle of the pins instead of like taking it right around the outside. And that's what a human would have done. That's why mine looks much cleaner. And then the top side of mine just looks cleaner. It just looks like a more human result. Anyway, we can actually like just accept current solution, I guess, if you're happy with, oh, right, stop. I'm happy with that. Don't rip up anymore. Once again, I didn't expect this to work. It's exactly, it produced the exact, or it's producing the exact result I expected, which is kind of like just all over the shop. It just looks like it's auto-routed. Nah, AI's not helping here. Once again, like keep out layers, like I didn't do any keep out layers. Anyway, you can see I turned the wires off there, and you can see that it shows the net. There we go. And you can see how, like the placement is ideal for this. Like each segment has its own chip, or two chips actually, which go to those two, like, so not much is like crisscrossing across the board and stuff like that. There are a few things, like there's a few common control lines down here. It's a big shift register. If you don't know, it's basically, data in and data out, and just drivers for the high voltage Nixie. Common drain drivers for the high voltage Nixie displays here, and Bob's your uncle. But unless it's absolutely uncritical and you really don't care, but have some pride in your PCB layout, please. From an old school PCB designer, have some pride, and don't do like have traces coming out of where. Look at this one coming back in and just going bleh, bleh, and then just coming along and then just going and going up at this angle. No, oh God, look at this one up here with this big jaggy like that. Oh, this is terrible. It's having a red hot go, but nah. It's our situation has not improved. This trace just goes up and way. Nah. Oh, look at this. It's going all the way. This trace here, it's going around here. It's dropping down a via there. It's going on the red layer up the top. Hopefully you can see that. My cursor's bigger on the screen. And then this goes around here, and then all the way back down to here. Like, it's going all the way up around this side of the board, and then all the way back. Nah, it's got rid of that now. This is its rip up retry thing, and obviously realized that was dumb. This jaggy on the bottom's still down here, and I just nah. I'm just gonna have to wait. Now you can see up the top right here, this is actually solution 16. So is it gone through like 16 complete? No, it wouldn't be complete. It like 16 rip up retry efforts, because I know some traces like this jaggy over here, this is not changed in several iterations now. So yeah, it looks like it's going through all these solutions. How it comes upon the best one, the AI determines what is the best one. Anyway, let's cast final judgment over the final board once it's done. But we have actually verified that there's no point sitting here watching it do its business. Although you can get a good idea that, oh no, I should have constrained it better. For example, I don't want it doing that sort of stuff, and oh, I forgot to constrain it here and here, and I probably should have put my ground plane down first. I should have laid down these high priority traces first and things like that. And you can get an idea of where it's goofing up. So this is actually a really good interface. I like it. Okay, it's been going 2 hours and 9 minutes now, and it's still only up to 100 and look, you can actually choose a solution. Oh, that's pretty cool. Just discovered that. So it's routed 196 out of 238 connections. So it's creeping towards there, and yeah, nah, it's still a yeah, nah. All right, I left it running overnight. It looks like it's locked up. It hasn't gone anywhere. It's exactly the same as it was. You saw in the previous clip, solution 48 at 2 hours and 9 minutes. It's just died there. So it looks like it actually died before I actually recorded the previous clip, because I came back at night and recorded that one, and I think it had already frozen. It's a fail. I've emailed support. Let's see what happens. Well, it's 24 hours later, and it did actually, well, it says it succeeded here. It took 1 day and 3 minutes, so I guess they're, pretty spot on with their 24-hour claim. But, yeah, look, the solution here is, sorry, you can't see it. It's only gotten down to 48 there. It's exactly where we were before, and it's only routed 196 of 238 connections. Now, I haven't heard back from DeepPCB about what happened here, but it obviously froze on that 48th solution there, and it looks like it's either refused to go any further because, I don't know, it backed itself into a corner or something, or whether or not we reached the limitation of how many nets it can do or whatever. But anyway, we've got the results here, and yeah, nah, it's crap. All right, so what I've got here is both the top layer and the bottom layer with the DeepPCB auto routed up the top and my manual route down the bottom. So this is this is DaveCAD versus AI up here, and no. This thing has no clue how to route a double-sided PCB. One of the golden rules for, or even multi-layer PCBs, take any of the old school boards. I've shown this before. Let me get it again. Okay, here's an old school PCB, okay, with through-hole parts. But stick with me, okay? You'll notice all the traces on the bottom there. Most of them are going left and right, horizontal, like that. And if you have a look at the top, they'll actually be going vertical. I know it's not, clear in there, but that's how you route a board, because you don't want to be caught. The first thing when you're laying out a double-sided board like this generally is that you don't want things going higgledy-piggledy, okay? This way, crisscross, because then you just run out of room completely and you have to add a ton of vias. Now, look at my board here, right? What I tried to do is I tried to route almost everything as a first pass on the top layer or the bottom layer, just on one layer. And in this particular case, I made sure that the two chips associated with the display are placed near, so that, and in fact, I even rotated the parts so that they were in the correct orientation. You can watch I've done a full layout video of how I laid out this board. And you can see all these traces feed in nicely into here, and you'll notice it's the same thing here, it's the same thing here, same thing here, right? Every display like this is what a human would do. It prioritizes groupings of components. That's another layout technique. You place components near each other that are supposed to be part of the group, and this is how your synergy with your schematic, when you draw your schematic, parts that are supposed to be close together, you make sure they're physically close together on the board as well. And then you're going to have the shortest routing path like this. But you'll notice that they, look, they've done a couple of lines here which are prioritized, but look at how this was easily routed like this. I just manually routed all these around, and it was, look, they were almost lined up perfectly to route them through like that, and they just haven't done that, right? Oh, look, they managed to get one which went all the way over there, but that's like, no. And look, in the end, it actually didn't route these nets at all. You'll notice that these were part of the nets that were unrouted, and like that was my first priority when I routed this board, is to make sure those segments are there, and then I could do the interconnections between the chips, like later, maybe on like a horizontal layer like this. But they've just gone higgledy-piggledy everywhere, okay? And next up, just look at some of the stupid stuff they've done here. This is just nutso, right? Go in here, look, what is this? Right? What is this? Why have we got 2V? Like, why is that going, and what is this? Going around to there? Just route it into there, for goodness sake, right? It's an absolute joke. Another one, just come in 45 degrees out of here. That's just stupid. No, you drop that straight down to there. And having these just like go into the corner, no, you have it coming out and then you branch up like that, out, and you branch over like that. Oh, come on, seriously? And what the heck's going on over here? Look, it's like that's going into there. It's like they haven't treated it as like the one physical net. Like they've just, treated it as different routing paths to take. It's just terrible. Absolute amateur hour, right? No, it's got no idea how to prioritize and route a simple double-sided PCB. And look at the bottom here, right? As a human laying out a board, right? You try and like get it all on the one layer, and then the stuff that you can't put on the one layer, you would put on the bottom, because then you'll be able to maximize your ground planes. You'll be able to let your power around and, stuff like that. So you notice I don't actually have that many like traces on here. Really, it's just actually joining some chips together and going horizontal like that, basically. And as you saw, all my top layer is just all vertical stuff, mostly vertical stuff. There's a couple of horizontal here that joins some of the like the common clock pin or whatever it was down here. But that's about it. I mean, this thing has no clue. To be fair, though, of course, it didn't know our intention. But even then, just some of the stuff it's doing is just awful. Look at this, right? It's just jagging off there. Why not just go like that, right? It's just, and this, just branching off there like that. It's just, no, absolutely awful. And it knows, right, that all these resistors should be connected like this, okay? And this is what I've done on my board down here. You can see I've just joined them all together as a priority, not because it doesn't know it's a high voltage trace and all that sort of stuff, right? And then like it comes down here like this and then branches up and then whoop, wiggles back like that, down and around, and it's like, what? And then they've like caught themselves in a corner here. No. And there's more weirdness happening around here and here. What's going on there? That's just dumb. And then this going up like that and then down. Oh, it's awful. Now, to be fair, the Altium one, I guess, is not a huge amount better. There's some, stuff around here. You'll have to go watch my previous video. It's got some reverse jaggies in there and, some weird branch offs and maybe a little overlap in there. Sorry, I can't zoom in on this. Don't have the original file to hand. But no, like, it is certainly, it's no better than a traditional auto router like this. It's just, no. So yeah, I'm very disappointed by this AI. It is just really dumb auto router stuff. There's nothing AI about it at all. There's no, it learns from its own routes. That's why it does it like multiple times or something. I would have expected multiple times for it to figure out, oh, look, there's some association, some, grouping some tight association over here. And if I go into the individual traces, we might actually be able to see, so like some issues where it just plainly has no clue what it's doing. It hasn't learned, it looks like it hasn't learned a thing. So I can't see any advantage to using this over, a traditional auto router, which is based on decades and decades of refinement for various algorithms, and you can set it up with tell it different algorithms, how many layer board you want. Do you want horizontal, vertical, priority, and all sorts of different algorithms you can actually select in any good auto router. You can actually select an optimal algorithm for it. But yeah, this thing's just, it's terrible, Muriel. That's a complete and epic fail. And did it just give up and couldn't complete some of the routes, even though they're like really obvious stuff, like, going through here like this? I mean, like, it's just, they're taking one trace through there and that just chopped off everything else, right? And like, a human's just going to know this stuff, even if the human auto router, and this is quite common in the industry actually, where you just have a PCB layout person. They didn't design the schematic. They've got no idea. They might even have no idea what the thing does. I know a lot of superb old school PCB designers who come from a drafting background. They got no idea about electronics, but they can see when you have the rat's nest, they can see the groupings up here like this. So DeepPCB AI, huge thumbs down. I expected better. No, I wouldn't bother using it. Yeah, just go back to your traditional auto router and just let it loose on very specific requirements that you got. You know, a board like this, you take some pride in your work, lay it out yourself, and it can be, you know, quite nice like this with minimal, you know, number of traces on the bottom going higgledy-piggledy, and then you got priority to your high voltage, your higher priority traces like the high voltage one and other, you know, stuff you can set up as a priority. But anyway, no, I expected better than that for a machine learning system that's supposed to learn from all those 48 passes it did, and it still couldn't figure out priority of stuff. So yeah, very poor. Anyway, if you found that video interesting, please give it a big thumbs up. As always, discuss down below and over on the EEVblog forum, and catch me on all my alternative channels. I'm on the Odysseys, I'm on the Utreons, I'm on the BitChutes, I'm on the Rumbles, I'm on the... I think I stopped being on Dailymotion. Anyway, I'm everywhere. Even on the EEVblog.com, old school, you can get the RSS podcast feed of this thing, which video comes directly from my own server. Been doing that forever. Catch you next time.